Alright, we're going to go ahead and finish up Module A now. The last section that we want to look at is section A.8. We're going to look at pictographs, bar graphs, and we're also going to look at line graphs. This comes from section 1.9 of your textbook. So let's go ahead and dive in. So let's go ahead and talk about the different kinds of diagrams that we're going to look at in this section. The first one we're going to look at is a pictograph. This uses pictures or symbols to display information. Bar graphs are similar. We use bar graphs of various heights to show quantity. And the last one we have is a line graph, which uses points connected by line segments to display a trend. So we're going to start with our pictographs. Note here that I'm going to point out a couple things. We have a symbol that we're going to use, and it's going to represent a certain quantity. So for instance here, each one of these little dollar bill symbols represents 1% sales tax. To figure out the sales tax for each state, you just have to go ahead and add them. So for instance, there's not much that we can really do with pictographs. One of the first things we can do is just go ahead and find a certain piece of information. So for instance, example 1, it says which state has a sales tax of 5%. And so we want the figure that has 5 full dollar bills, and that's going to be Idaho. Okay, the next thing we want to do is we want to go ahead and we can also find differences or find sums. For example 2, it says by about how much does Idaho's sales tax exceed Georgia's sales tax? Well, we know that Idaho is 5. Georgia we have is 4. And when we're asked how much does it exceed, that means what's the difference? So we want to subtract these and we get 1%. Okay, now real fast, can you tell me what the sales tax for Utah is? So note that you do have a part of a dollar bill up there. And so I would say that this is one we're going to have to estimate. And to me, it looks like it's a little more than half, so I'm going to say 4.75%. So note that if it is a portion of your picture, you are going to have a fraction or a decimal. Okay, let's try one more. Okay, we have school language clubs membership. And this is kind of a double pictograph. Note here that we have female students and male students. So if we go ahead and look at this, we want to know what is the total number of members in the Chinese club. Well, it looks like we have 5 female and 7 male. And so I get a total of 12. Okay, which student club has the least number of members? Looking at this diagram, it looks to me like the Spanish club has the fewest members. Okay, so it says now, how many more female students are in the French and Spanish clubs combined than male students? So in the French, how many female students do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. Plus the Spanish, 9, 10, 11, 12, 13, 14. minus how many male students do we have? In French and Spanish, we have 5 in French plus 4 in Spanish is 9. 14 minus 9 is 5. The other thing that you could do on here is you could just add up the extra female students. As you can see, this doesn't get very difficult. It's mostly a matter of counting. All right, that takes care of our pictographs. So let's go ahead and look at our next couple of examples. Okay, so the next thing we're going to look at is a bar graph. Now this is a double bar graph. So note again that we have 2 things for each freshman, sophomore, junior, senior year. Our white graph is our male students and our gray graph is our female students. So it says how many more male freshmen are there than female seniors. So for male freshmen, I'm going to come to my freshman column and I'm going to look at my white bar. We have 500 male freshmen. Remember that how many more implies subtraction. We want to know female seniors, so I'm going to come over to my seniors, my gray line, and I'm going to trace it over to here. It looks to be about 250. That's halfway between 200 and 300. And if we subtract this, we get 250. Okay. The next thing we want is we want to know how many more sophomores are there than juniors. So sophomores, we need to figure out the total. We have 400 guys, 450 girls. Total, that's going to be 850. All right, juniors, what do we have? We have 350 male students and 300 female students. That's going to be a total of 650. And if we subtract, we get 200. Okay, finally, the last thing we have is which class has more female students than male students. So where is our gray bar higher than our white bar? And that's going to be sophomores. All right, that takes care of a bar graph. The last thing we want to look at is line graphs. So this is a double line graph. Again, note that we have 2 different line pieces going on here. We have the dashed and we have the solid. So the dashed line refers to store A. The solid line refers to store B. So it says what trend or pattern is shown in store B from 2003 to 2005. So store B, we're looking at the solid line. And what happens as we go along the solid line from 2003 to 2005? It is decreasing. Okay, now let's go ahead and look at problem number 2. We have what is the estimated sales for store A in 2006? So in 2006, we are right here for store A. This is 35, but we do need to be careful. If you look at the side of your graph, it says annual sales in hundred thousands of dollars. So that means that this is actually 35 times 100,000. If we go ahead and multiply that, I have 35 followed by 5 zeros. And so that should actually be $3,500,000. So when you look at line graphs, make sure that you pay close attention to what we refer to as the legend. The legend tells us what this is actually increasing by. That way they don't have to write out so many zeros on this. All right, that takes care of our double line graph. Let's look at one more. Okay, let's go ahead and see what we can do here. Number one, we have what trend or pattern is shown in the graph. So what happens as we move from left to right along this graph? We have that it is increasing. It is going up from left to right. We want to know what was the annual net sales in 2003. In 2003, we start with 4,000. But we need to include our legend. We want to multiply this by 1 million. And so if we do that, we get four followed by 9 zeros, or 4 billion. The last thing we want is which year had the largest increase over the previous year. So we're looking for the steepest line, and our steepest line occurs from 2006 to 2007. All right, that takes care of different ways to represent data. Right now, as we are still in the middle of the coronavirus, we still have lots of ways to represent data, and if you watch the news or you read the newspaper or are online, you probably see lots of different types of these representations. We will revisit this later on this semester when we can do a little bit more with some other tools. But this is just an introduction to different ways to represent data. That takes care of Module A. I will see you again shortly to start Module B.